That's okay. All right. So this is at the top of this. Let's put topic 6. Okay, so this is topic 6 for review. What I want to do is make sure you got the basics. Now remember, there are a lot of rules in what we've done for these different chapters. I want to make sure that you see them and remember what some of those are, detail-wise. So one of the first things I'd study for your exam are these note sheets. Okay, so first of all, an exponential, the form that we have for this is y equals a times b to the x power. Okay, and remember what we had is that we now have, for an exponential, we have the variable in the exponent. Okay, all right, so the graph for this, when we do an exponential, okay, typically what the graph will look like is it will look like this type of graph going up. Okay, now, if b is less than 1, this is with b greater than 1, the base is greater than 1. If b is less than 1, the graph is going to come down. Okay, so b will be less than 1. Never gets to the x-axis, that's an asymptote. X-axis here is an asymptote. And we move them up and down by adding or subtracting a number, okay? All right, our applications for this that you need to remember, and I'll be giving you these forms for it. This will be exponential growth. And the typical one we do for exponential growth is interest. Remember the interest problems we did? You know, where you compound the interest maybe monthly or compound it weekly or daily. Compounded continuously was also another option, okay? Now, another application is exponential decay. Exponential decay is typically where we do the depreciation problems. This is where we talked about, with depreciation, we talked about having, for instance, buying a car and then having it depreciate over time. Okay, so those are the types we do with it. Now let's go ahead and go over some of the log information. You were introduced to logarithms in this chapter. Okay, the form for a logarithm is y equals, and you're going to have, for the log, you're going to have log base b of x here. So x goes on the inside of it, okay? Now we did that, if you recall, these guys are inverses of each other. So exponential and logarithm, they're inverses. Okay. Let's try that again here. Okay, so when we talked about inverses in chapter 5, we then extended it here to exponentials and logarithms. Now we had 4 rules that you have to remember for this. Okay, then these are important rules. These are not going to be given to you. These 4 rules, you need to remember that if you multiply 2 things inside of a log, that means you can take the 2 logs and add them together if they've got the same base. So 2 things multiplied inside of a log, we can add the logs. If you've got 2 things being divided inside a log, then we subtract them. This is based on what those rules we talked about with exponents yesterday. When you multiply 2 things with the same base, you add the exponents. And when you divide 2 things, you subtract the exponents. That's what these rules are based on, okay? Now this one, you've got the c up on top here, you need to bring it in front. So that's where you had outside the parentheses, an exponent. You brought it in, you multiplied it by the exponents that were listed there. And this might be the most important one. This is called the change of base theorem. Change of base theorem says that if you've got any base, if you want to use it on your calculator has a log base b key, but you can also just do log base 10 of a over log base 10 of b. So when there's no log listed, okay, no log list or no base listed, log base 10 of a is the same as just log of a. No base listed, it's base 10. Okay, that's something that we learned. Okay, so we'll be using that change of base here in just a moment, but that's something that you will be using. All right, so here's some problems. Remember when we did these? We did the circle tour. So when you converted it, we did a circle tour where we said 5 to the third is equal to 125. You got really good at the circle tour. That's something that you want to make sure you use when we convert it from a log into an exponential. 5 to the third equals 125. This one we're going to graph and state the domain and range. This number here, this is going to move the graph down 5 units. So there's going to be an asymptote at -5 down here. So I'm going to just draw it down here. This is at -5. That's what this does. So down 5. This here, remember the number in the exponent here, this is going to move it, this actually moves it to the, since it's -4, it moves in the opposite direction. It moves it to the left, it moves it to the right 4 units. Now you don't have to worry about that one. Your chart will tell you on your graphing calculator. We'll get to that. And then these other things like the 1/2 will just move it down and things like that. You don't have to worry about it. All right, so the big thing for this is really what you need out of this, is if you have a plus or minus number here, draw an asymptote there. That's the important part of learning for those. All right. Remember, when we got our iPads out, we're not looking at other stuff. We're paying attention and also maybe looking at a key. All right, let's go ahead and turn this on. We're going to go ahead and put that into y equals. The 1/2 has to go in a parentheses. Don't forget, fractions have to go in parentheses. So 1 divided by 2, I'm going to take that times 3 to the x plus 4 power, x minus 4. If yours doesn't go up like this, remember to put it in parentheses. This one I don't have to because it goes up, so x minus 4. Okay, now bring it down, and then I'm going to put a -5 there. So put in the numbers, and you get those values, okay? All right, so we want to make sure we've got those in. You've got to know that there's a whole section in the written part on graphs. There's a likelihood that it'll be one kind of like this. So this is a good idea to make sure you get this. The first thing is get your asymptote, then go ahead and look at the graph. So I'm going to go with zoom, and I'm going to do a standard graph. Notice that's down there at -5, very close to it, and then suddenly it takes off because it's been moved over to the right 4 units. So all you need to do is go to your table, get some values here out by 4. So notice at 4 it's at -4.5. 4 is at -4.5. Get a couple more values here. So let's see, 6 is at -0.5. And just to get the shape, and 7 is at 8.5. So let's go ahead and plot those. So 4, negative 4.5 is right about there. 6 is negative 0.5. 7 is way up at 8.5. So I've got it following along with this asymptote here. And then it hits here and it goes up pretty fast. Don't pass the asymptote here. It's got to get close to the asymptote. It doesn't actually go past it. Okay. Asymptote, see how critical that asymptote is to that graph. Right. Pause a moment, just make sure everybody can get that written down. The detail, then we'll do some solving here. All right, so for solving here, what you want to do is you want to get the same base on both sides. So when you're solving with an exponential, what you want to do is here, I want both of these to have the same base. Well, 7, I can't move that down any further, but the 49 I can make into a 7 squared. You see how if I do that, I'm going to have a 7 on both sides? So you create the same base on both sides by saying, hey, this can be 7 squared, it's the same base, and then there's just the x plus 5 on the outside. Now, when we take this, you have 7 to the 3x plus 1. Remember our rule? If you have an exponent on the outside, you bring it in and multiply. So this is going to be 7 to the 2x plus 10. Now, same base with exponents, set the exponents equal. You can drop the bases off. That's the technique for it. So 3x plus 1 is going to just equal 2x plus 10. That becomes a doable problem. Once you get rid of the bases by getting to be the same, set the exponents equal. I'm going to go ahead and subtract 2x from both sides. I'm going to subtract 1 and I get x equal to 9. These problems you do not have to check unless you just aren't sure that you did it right, okay? You're not doing anything that will create extraneous solutions. All right, this one looks like a crazy problem. I mean, I don't know who would ever do log base 12 of anything, but that's where, if you can get the same base on both sides, just like here, same base on both sides, now all you do is you set the inside parts equal. So x squared is going to equal 2x plus 3. Now it's not so hard. If you get the same base on the logarithm, set the inside parts equal, and now we solve. So I'm going to subtract 2x, subtract 3, get it equal to 0. When we have an x squared, you get it all on that side. Then you factor. I want two numbers that multiply to get me that -3 and add to get -2. Well, it's -3 and +1. And so you get x minus 3 equals 0, x equals 3, x plus 1 equals 0, x equals -1. Okay. Now you get two answers. Now, we didn't have to check that one with exponentials, but you do have to check it with logs. Check, and the idea is no negative in a log. If I put in 3 into here, that's positive. If I put in 3 here, that's positive. We're good. So 3 checks. All you have to do is make sure it's not negative. If I put in -1 and square it, I get a positive. -1 here, -2 plus 3 is still a positive, so we're still okay. Both of them check here. So you get both these answers. X equals, gotta rewrite this. X equals 3 and -1 are my two answers. All right, so last two problems. We're almost there. So this first one here, because it's base 3, remember this rule up here? This rule up here said, if you've got two things being added, I can bring them together and multiply them on the inside. So two logs being added with the same base. I'm going to go ahead and take these together and make it log base 3 of a times 6. You can bring them together and multiply. Log base 3 of 72. Now, once you have the same base on both sides, remember what we did up here? Same base on both sides, you can set the inside parts equal. So just the 6a equals the 72, divide by 6, and you get 12. Check it. If you put 12 back in, you do not get a negative anything, so that is your answer. Can't take the log of a negative. All right, the last one is for our calculator. Okay, I just want to remind you, because you'll see this probably in the multiple choice, okay? On this one, you want to take the log of 90 over the log of 8. This is the change of base theorem we talked about. Change of base. Okay, I can't write backhand, it looks like. So change of base, we're going to do that on our calculator. So I'll hit here, second quit, and we're going to do log of 90, and we're going to divide that by log of 8. And we get 2.16 as an answer.